Okay, so let me introduce the next speaker. He is leading a huge research project here at NTNU, Professor Asgeir Tomasgard, and he's going to talk to us about the role of Norway in providing the flexibility and the balance that the European power system needs. Asgeir.
Thank you. So my presentation is going to be about mostly the electricity system, but also some links to the rest of the energy system. And the presentation is going to be based on some work we did in the research center Census, where I'm a director, and jointly between NTNU and SINTEF. For those of you that would like to look more into the details, please look into this report. I think if you look at it, it's clear that we need to go towards a zero-emission power system. And this needs to happen in a period of 30 years. And this presentation takes an assumption that you may say is naive. It's an assumption, can we minimize the transition cost to move to such a power system? What does it mean? It would mean that all the European countries are actually cooperating in the long run to build the most cost-efficient electricity system. And this might not be exactly what is happening today, but it may be what we need to happen in the future. And the reason why I look at this from a Norwegian and European perspective is, in Norway, we already have an electricity system that on an average year is 100% electric. We have an electricity 100% renewable with hydropower and a little bit of wind. Europe needs to go in that direction. Not necessarily those sources, but also Europe would need to have a zero-emission electricity system in 30 years. And that's the challenge. At the same time, the electricity demand in Europe is projected to increase, as, for example, outlined in the EU reference scenarios from 2016. So I would say that's a moderate increase, considering that the rest of the energy system is also going to be close to zero emission. It's not only the power system that is going to be zero emission, the whole energy system needs to be very close to zero emission. That means a large-scale electrification of society over the next 30 years. This means that this projection of increase in electricity demand might be too modest, but at least it's a good starting point to discuss. We are going to increase demand a little bit, and we are going to reduce emissions from this point, where we were in 2010, down to almost zero. So we have assumed here a 90% emission reduction in the numbers I'm going to show you. And I think that's going to be challenging enough. My personal view is that it needs to be zero emission. And I look at two different baseline scenarios into this work. I mean, this is not the future. These are two potential stories about the future. So given the input that we use for analyzing the next 30 years, the best available data we have on how technology cost will evolve, how efficiency in different technologies will evolve, how fuel cost will evolve. We insert that into these models, and we tell two different stories about the future. Which one will happen is very much up to the politicians. And it could also be other stories that is not presented here, of course. But the main idea in both stories is that emissions needs to go down, while demand is increasing slightly. So in these two particular stories, we could have a development like this. So this would be the time evolving towards 2050, and this would be the installed capacity in terms of gigawatts, and this would be the generation in terms of terawatt hours in the European power system. And we see the different technologies and how they evolve. So this would be nuclear, this would be unabated coal, so coal where you don't have CO2 capture and storage. This would be unabated gas, and this would be the carbon capture and storage, where you capture the CO2 from the exhaust and store it permanently, for example, in the Norwegian continental shelf. Hydropower, wind onshore, wind offshore, and solar PV. And of course, this mix will depend heavily on what kind of cost development is assumed into such models. But I think it's interesting to observe a small part of this table, not all. 29% of the installed capacity might be solar, only 17% of the generation, and that's because the sun always shines, not in Trondheim, in the middle of the day. And it's quite easy to predict that it will not be shining in the morning and afternoon and the middle of the night that much. Wind onshore has a different characteristic. It's 38% of the capacity and 4% of the generation. But if you look at natural gas with CCS, 4% of the capacity and 11% of the generation. And that points at a very important feature. You need some type of electricity that is controllable and that you can plan. Norwegian hydropower would be a different source which has the same kind of capabilities. I think it would be interesting also to have a look at the difference between the scenario with and without carbon capture and storage. What happens, of course, the amount of gas you use, if you don't have carbon capture and storage, is reduced to almost half, and renewable takes its place. And in this situation, you would have solar 1/3 of installed capacity and 20% of the production. I mean, these are possible stories about the future, but I think you get the idea that in a system like this, without carbon capture and storage, you would have around 80% renewables in a likely setting. And in such a situation, it's also interesting to see how different countries could contribute to the transition. This, again, would be carbon capture and storage. And countries like France and UK, Netherlands would still rely on gas to some degree, using carbon capture and storage. Other countries would have solar, wind onshore, wind offshore. Norway would have hydropower, wind onshore, wind offshore. And if you look at the situation without carbon capture and storage, I think it's quite interesting to observe how this slides, but you could see that you get some more solar into the system. And if you look at Norway, I think that's a very interesting observation. You see what happens with offshore wind. So the rest of the system is more or less constant, but there will be a massive investment in offshore wind into the Norwegian system in such a situation. And this is not energy that we would need ourselves unless we build an enormous amount of industry to take off that increased energy volume. I mean, this would correspond to something like 80 gigawatts of installed wind outside the coast of Norway. It would, in comparison, be the Norwegian hydropower today is 30 gigawatts of installed capacity. So this would mean that we would build every year for the next 30 years 2 gigawatts of offshore wind outside the coast of Norway. Just to put this in perspective, this is not about the power price next week. This is about saving the future European electricity system. One thing that makes me worry about this kind of numbers is if you look at the transmission infrastructure. So this would be more or less the situation in 2010. These are two predictions for the European cross-border exchange 30 years from now. And if you look at the numbers, it's a 700% increase in the baseline scenario. It's an 800% increase in the scenario without carbon capture and storage. Today, it's difficult to build one single transmission line from the north of Germany to the south of Germany. And you can imagine what kind of discussion a development like that would lead to. So why do I present it? Well, I present it because this is what the model suggests would be a solution, and a solution that would be the cheapest solution for Europe. And if you would curb building of transmission, you would have an enormous overinvestment in renewables, and that renewable would then need to, in many places, not go into the electricity system. It would need to go into other sectors of the economy, like transport, like hydrogen production, hydrogen used for heat. So this is not the only solution. There are other solutions that would involve a much higher integration of the energy system. But if we want that development to happen, we would need also to start focusing on the sector coupling to a much higher degree than we do today. And that would be coupling with natural gas, carbon capture and storage, hydrogen, and the use of electricity into sectors like transport industry, but with a much higher electricity demand increase than in the projections from 2016 in the EU reference scenario. So that would really bring us to a system like this, which we did not analyze in this report, but I think could change the previous picture, where you would look at the integrated energy system at a local level, and you would have much more integration between the heat system, the power system, the transport system, and industry locally, so you could take off some of that need for moving large amounts of energy in space. Personally, I think you will still find that transmission would be one of the cheapest solutions for flexibility in the European system, utilizing that the wind isn't blowing at the same time in the North Sea as in the eastern part of Europe, and you would need to be able to move large amounts of energy in a renewable electricity system for Europe. But the sector coupling and the coupling up towards the other energy sectors and industrial sectors will be critical. If you look at the decision space for countries like Norway, I think it's important to then focus a little bit on some of the numbers. So this would be an estimated generation of electricity in 2050 from hydropower. So it's about the same as we have today in terawatt hours, not an increase. And the reason is we hasn't allowed the model to invest in more hydropower in Norway. We say that the hydropower amounts we have in Norway today has been like this for quite a while, and if we invest in new hydropower, it will be run of the river. And we see there's a little bit of investment in that, so this would be the regulated one. If you look at wind onshore and wind offshore, it's 50 and 60 terawatt hours. So this would correspond to some 30 gigawatts installed capacity of onshore wind and offshore wind. And this is the situation with carbon capture and storage. What would it mean? It would mean that we build 1 gigawatt of installed capacity for offshore wind for the next 30 years. This one, without the carbon capture and storage, it would probably mean that we need to build 80 gigawatts in the North Sea. So this is a bit utopic, maybe, but this is what we did in the natural gas sector. This is what we did in the petroleum sector. It's the same type of investments, and if you want to look at how we are going to develop Norwegian industry, how we are going to develop Norwegian society for the next 30 years, this is the kind of decisions we need to make. This might be what we are going to live from. And one alternative could, of course, be natural gas, CCS, hydrogen production, going into the European industry, into European heat sector. But the fundamental question would be, so are there any buyers of this? And do we have any dialogue with the potential buyers of this? So just to illustrate with some small examples what it would mean to the Norwegian hydropower system. So this is wind generation in northwestern Europe. This is solar generation in northwestern Europe on a typical week in 2050. So this is not a weather forecast. This is a potential possible week in 2050. This would be the solar, and you see the bumps. Now the net load, and you see the bumps in the middle of the day. The net load is when you subtract the wind and the solar and the demand response. And this is the operation of Norwegian hydropower, going at what you could say would be max capacity when the wind isn't blowing, going down to zero when the wind starts blowing. Wind stops blowing again, it goes up to max again, and it continues like that. If the Norwegian hydropower system is going to be operated like that, you would need to invest massively in pumped hydro and tunnels to pump the water back up in the reservoirs again, and in more peak capacity on the generator side. So again, the question will be the same. Seems like Europe is going to need this capacity, but how can we make sure, if we start developing this kind of capacity, that anyone would actually be willing to buy it when it is there? Because these are heavy and major investments. And I could show some pictures for natural gas saying more or less the same, and again, the natural gas system would be capable of delivering that type of flexibility, but it depends very much on carbon capture and storage or not. Remember, the volumes for natural gas in the power sector will be reduced to half without carbon capture and storage. So the numbers for northwestern Europe would be the same, and you can say that these volumes coming from Norway in building capacity on the Norwegian part of the continental shelf, well, it's matched by the rest of the North Sea area. So the countries around the North Sea area will need to make investments in a similar scale in this kind of technologies to make sure that the electricity system is going to be zero emission. And remember, I had a very conservative estimate on demand increase, not recognizing the fact that we probably need to electrify even more sectors than the EU reference scenario was saying. And to me, this points at one of the major challenges in developing the future energy system of Europe and electricity system of Europe. You need to have much more sector coupling than you have today, and you need also probably to have a lot more cooperation to make these things happen. So I'm going to summarize. Natural gas might still play a role. It will depend on CCS. Onshore wind seems to be very significant, but offshore wind comes in and take a major role, and I think who is going to be the winner? My personal guess would be offshore wind because of the volumes we need. These volumes are so huge that we would need to learn how to implement offshore wind in an efficient way. Transmission is the favored flexibility measure in this type of models, but it's not the favored flexibility measure with the population. This is going to be a major challenge for us. And hydropower is a unique resource that could actually do this ramping from 0 up to 30 gigawatts of capacity in Norway during a very short period of time. So the main conclusion is we talk about massive investments, either in carbon capture and storage infrastructure, either in large-scale offshore wind, either in large-scale transmission, or in a complete change of the local energy system, where we will have a much higher sector coupling between heat and electricity. And we need to develop long-term policy. If we would believe in the offshore wind part of this scenario, that we're going to install between 1 and 2 gigawatts every year for the next 30 years, that would mean that we need a plan for how to develop the North Sea together with our neighbors. And that would mean that we need to establish a policy saying something about how is the profits coming out of this development going to be shared, how is the risk coming out of that development going to be shared, what part of it will go to the industrial companies developing it, what part will go to the population as part of utilizing a national resource, like for natural gas and petroleum. And of course, when you're building that kind of large-scale solutions, you need to have a good dialogue with the buyers of the electricity, because I think we need to realize when you talk about these kind of volumes, we are not going to build that much industry. We are going to build more industry based on the resources, I think, but these are completely different volumes. And we would need to then have a good dialogue with the customers of this electricity. And again, these are a few stories about the future. They will not happen, but something similar could happen, and it will depend very much on what type of policy is made. Thank you.
Thank you so much, Asgeir. That was a really comprehensive look at some of the options facing you here in Norway, but also European policymakers facing the whole system. What are you going to take away? So he told us a lot of stuff, right? Stop for a moment, please, ladies and gentlemen. Think about what it is you would like to drill down into further. Excuse me. That extraordinary graph of the transmission systems and how they got thicker and thicker under different scenarios. Is that something you're going to ask him about? Are you going to ask him about what seems to be a kind of trade-off between offshore wind and CCS? Have I read that right, Asgeir? Is that something you might want to find out more about? Are you going to ask him more about cooperation, European cooperation? You know, is that as elusive as pigs flying? There are many thoughts he's given us, right?